Okay, we'll start now. Okay, last class we discussed about router security, right? So how do you secure your router? So router security basically it's nothing but setting in the password to the router. So we have a way to set enable mode password, and also there is a way you can set the password to the console interface of the router. Right? We discussed this in the last class. So in today's class we're going to discuss about something called remote access, right? Which is really important because everyone does it. Any person who's working in networking will definitely do this remote access. Okay, we're going to understand remote access. So there are two ways of remote access. One is Telnet, okay, and the other one is SSH. Okay, I'll tell you, what is Telnet. First, we'll go with Telnet, and I'll tell you why Telnet is not recommended, and I'll tell you why SSH is good. Okay, so we're going to learn Telnet and SSH today, and also we're going to start OSPF. Okay, so the one and only routing protocol that we have right now in the CCNA course. Okay, so we'll start now. Let me take it to the lab. Okay, so in the lab, we can get into NG free labs and then CCNA Bootcamp. So you can see there is an 8th lab, which is Telnet SSH. Let me open it. And you can see it's a very simple lab, doesn't have much devices, right? A couple of routers. One is ISP here, the other one is router 1. And we have few Windows machines and we have this internet user also. Okay. Yeah, so now what I'm going to do is I'm just going to go and start all the devices. Okay, so let them start. Before that, I'll tell you what is the purpose of having remote access. See, we all know, right? I don't know how many of you have used this application called AnyDesk. AnyDesk, there is an application called AnyDesk. Right? If you have used it, just mention in the chat. Okay, there is an application called AnyDesk, and also there is an application called TeamViewer. Okay, so TeamViewer is another application, right? These are the applications which is used for remote support. See, if you have used these applications, then you will very well know what is the purpose of it. AnyDesk or TeamViewer, if you have used it, then you know what is the purpose of it. It's nothing but a remote support. For example, let's say I can give you an example like this. Now assume this is my PC, okay, and I live in Chennai. Okay, and I have a friend. He has got his PC and he's living in, let's say, he's in Hyderabad. Okay, now what happens is my friend has got some issue with his PC. Right? Maybe he's not able to install some applications. Maybe he wanted to install MS Office. Okay, he's a non-technical person. My friend is a non-technical person. He wanted to install MS Office in his PC, but he don't know how to install it. So what he does is he's just giving me a call. I'm in Chennai, and he wanted to install MS Office in his PC. Right? I have two ways. One way is I can just take a flight, go to his home, and I can install MS Office, and then I can come back. Right? So this is very expensive and a time-consuming thing also. So instead, what I can do is I can ask my friend who's in who's in Hyderabad. I can ask him to install any of these applications. For example, assume that AnyDesk is a little popular than TeamViewer. So I'm asking him to install an application called AnyDesk, right? And after installing AnyDesk, what happens is now once you launch this AnyDesk application, maybe I can even show you that, but don't control my PC. Okay, so you can see my AnyDesk ID. Yeah, so this is my address, right? Don't connect with me, guys. Okay, so this is my address. So the same way, right, in his PC, he'll have some kind of a AnyDesk ID. For example, let's say 730100727 something like that, 721. Now he need to share this ID with me. So now what I can do is from my PC itself, understand? From my PC itself, I can use his address and I can connect, right? I can use this. This is the address that he has got, right, in his AnyDesk application. Now I can use that address and I can remotely take control of this PC, right? Can you understand what I'm trying to say? I'm taking remote control of this PC and I can install this MS Office application for him, right? And I can, give him the PC back to him, which means instead of traveling to somewhere, right? This with the help of applications like AnyDesk or TeamViewer, the advantage is you can take remote support and you can control their PC from this location, right? You can be in whatever location. Still, if he has got internet access, if he need to have internet, and you need to have internet, right? If both guys are having internet, with the help of this AnyDesk or TeamViewer application, you basically share your address to him, and he can connect with this address, and you can access your PC. Right? This is so easy, right? See, this example is what remote support is. So remote means I'm accessing. Remote means what? Remote means you can be wherever you want. That is what remote is. You can be in wherever location in the world, but still you can support. Okay. So this application is very popular. AnyDesk TeamViewer are very popular. And now the same thing is even required for a router configuration or switch configuration. Assume now the router, right? Assume that my office is in Hyderabad place, right? Assume this is my office. Okay, this is my office, and in my office I have a router, and assume my office is in Hyderabad, or it can be in any location. Okay, so now usually what I do is, I come to my office, to my Hyderabad office. I work there. I sit there. I work there. So maybe assume that I came for a vacation, right? I went to some different place. Okay, let's assume that I went to Sri Lanka. Okay, and my office is calling me and asking for some support. Okay, they want to do some configurations on the router. My office in Hyderabad. I went to vacation to Sri Lanka. Now from there, I need to configure, or I need to access my router. Right? Again, what is required? Again, I need to remotely. Again, the same concept. So I can be in any location. The router can be in any location. Right? Still, I'll be able to remotely access my router and do the configuration. I don't have to, break my vacation and come back to the office and do the configuration. I can sit wherever I want, and I can still be able to control my router. This is a really cool, nice feature that we have, so that if you wanted to configure a router, right, you don't need to be physically near the router. Okay, there is no need to physically be near the router. Can you understand what I mean by physically near the router? You don't have to be near the router physically, which means you don't have to go to the location of the router. You can be in any corner of the world. All you need is just a simple internet access, and you can control your router from whichever location you are in. Okay, that's what we are trying to understand here. So this is a simple lab. Let me take a screenshot of this lab. Okay. So here, what we are trying to do is here, assume that this is a company, right? So this company has got a router here. Okay. So generally, what happens? So this is the office environment, and this is our office location. Assume this is the location. Now, generally, how we configure router is what we have learned in the previous class, right? If you want to configure a router, what is required? A console cable, correct? A console cable is required, and we connect the console cable to the console interface of the router, right? And then we connect the other end of the cable to the laptop. Okay, this is my laptop, assume. Okay, and I need to install some terminal emulator applications like Putty, and I can use the connection type serial. So this is what we discussed in the last class. Okay, serial type, serial connection, and then I can go and connect with my router, right? See, the console, this connection is what we call as console connection, right? Console connection, console connection. So this console connection can be done only when you are physically near the router, which means you have to go near the router, take this cable, right? You can connect the cable to the console interface of the router. The other end should be in the laptop. So which means, can you understand how far you can be, guys? Right? This distance between the router and you, the distance can be maybe 2 or 3 feet only, right? Because you cannot be very far away. So right, 3 feet means very short. Maybe one meter or 2 meters of distance only you can have. Maybe depending on the size of the console cable, right? You can be little far also, but not definitely more than 7 or 8 meters. Right? That's the maximum distance that we can keep. Now that's based on the size of the console cable I can connect. If this cable is long, I can be little away from the router. But again, console cable, the distance of the console cable is not going to be definitely more than I see. I have not seen the maximum I have seen is only 5 meters, 5 to 10 meters. It should be somewhere in between that range only. Definitely not more than that. Okay, so now this is a physical connection. So console connections are always called as physical connection. Why? Because physically we have to be near to the router. Okay, yeah. So now, so what happens is, assume that this is our admin. Hey, this guy. is our admin. And what our admin does is, right, assume the admin, assume this is a company, right? And this is a place where the router is, and this is the admin PC. So whenever the admin wanted to configure the router, what the admin do is, the admin will just walk to this place near to the router, maybe a few meters he's walking, going near to the router and connecting the console cable and configuring, right? Assume that this is the admin, right? He sits in generally in this place. But whenever he wanted to configure a router, he travels, he walks some 120, 200, 200 meters to the router that is in the office itself. Can you understand? This is the office location. Okay, so in the office location itself, admin is a little far away from the router. So he goes to that, he walks for just 2, 3 minutes of time, goes to the physical location of the router, connects the console cable, takes the laptop and configuring it. Okay, so now the admin feels, always he wanted to walk for that, 2 to 3 minutes or 5 minutes walk he need to make and then go and configure the router. He doesn't like that. So what the admin wanted to do is, the admin want to remotely access from the office itself. Assume the admin is in the office, the router is also in the office. Instead of walking for 2 minutes just to reach the router, he doesn't want to do that, because every time walking 2 minutes and doing something, again coming back, again walking 2 minutes, doing something, coming back. So he doesn't like it. So what admin is expecting to have some kind of a remote access. Okay, so that's the story that we have here. So this admin who's using this PC wanted to remotely access the router, remotely control the router. He doesn't like to walk for that 2 minutes of time. Okay. So now what admin is going to do is, like, let's take this admin PC. Okay, I think this is the admin's laptop. Now what he's gonna do is he's gonna remotely access it, right? And admin decided to use a protocol called Telnet. Okay, so Telnet is nothing but a service, I can say, or a protocol which is helping us to remotely access the devices. Okay, so admin is using this Telnet protocol to connect to the router. Okay, so you will understand, guys. If you're not understanding it, don't worry. So once I do the labs and once you guys do the labs, you'll be able to understand definitely. Okay, let me click on this putty application, and then there you have the host name or IP address. Can you see there is host name or IP address? What is the IP address? So right now I'm in this device. Okay, let me undo these things. Okay, I'm in this device and I have got an IP address of 1.2. What is the IP address of this admin? Sorry, what is the IP address of this router, guys? 1.1, right? So let me go to the let me type the IP address, right? I'm just gonna connect with whom? I'm gonna connect with the router. What is the IP address of the router? 1.1. Right? Let me open. Okay, sorry, the protocol should not be SSH, it should be Telnet, right? So we'll go to SSH after some time. Now we'll just go with the Telnet. That is the first protocol we're going to learn right now. So I'm trying to choose Telnet protocol and I would like to remotely access the router with the protocol Telnet, right? Let me just give open. And now what I see here is, the error that I'm getting here is connection refused. The Windows machine getting an error saying that the connection. What exactly happened was, this PC was trying to establish a Telnet connection, right? He is trying to control this router, okay, with the help of Telnet protocol. He's trying to remotely access the router, and the router says he's refusing it. The router says no, no, I'm not gonna allow you to control me. Because why this guy says no is because that is what the default behavior. By default, the router will not accept Telnet connection. By default, the router will refuse. Okay, it's gonna refuse the remote access, right? If I write RA, understand it's remote access. So by default, routers will refuse remote access because no routers can accept remote access, right? Everyone should refuse by default. That is a good security. So any router you take, they're gonna refuse the remote access by default. So now what I have to do is, I need to go to this router and I'm gonna go to the router and I'm gonna enable the remote access, right? I'm just gonna enable remote access. So RA remote access. That too, particularly, I'm gonna enable Telnet right now. Okay, Telnet. Okay, so I'm gonna enable Telnet right now. Let's go to the now assume that the only option that we have is what, right? We cannot control the router now through Telnet because we have to enable remote access. So what I'm doing is just assume that I went to the router, connecting the console cable, and through putty application, I got the access of the router. Now, through this console connection only, I need to enable Telnet. You got the idea? You can enable Telnet from a console connection. Right? Yesterday we did console connection. So after connecting via console cable of the router or console cable to the router from this PC, I can get the console connection, and through that console connection, I can enable Telnet. Okay, that is what I'm going to do. So what I'll do is, now I'm going to click on this router, right? which is kind of console connection you have to understand, right? So clicking on the router here is equal to, connecting a console cable, right? Because in this lab, we just click on this and we get the console. But in reality, how you get the console? You need a console cable and you need a laptop and you need to have this application installed. Okay, so now let me just go and then I'm into the router. So right now, what I'm going to do is, guys, I'm going to go and create a username password, right? So I'm just going to create admin1 username. We did this last class itself, right? So again, secret admin1 pass. Yeah, I'm going to create one more user account, username admin2 secret admin2 pass. Okay. So now let's give do show run to see that we used this command in the last class, do show run. Of course, we have the user accounts created. Good. Now let's go to the point of enabling the telnet connection, which is remote access. Now, when I give line, and then I'm going to give VTY, right? VTY stands for virtual terminal. Okay, so that's what exactly, it's exactly virtual teletype, but we'll call it like, virtual connection, kind of a remote access connection. So line VTY, and I'm going to give you, I'm going to set the number of remote access connections the router can accept at the same time. So I'll go to 0 to 4. This is a traditional configuration, guys. Some guys go with 0.4, some guys go with 0.15. Okay, I'll just go with 0.4. What I mean by that is, which means the first remote access connection. The first remote access connection, the first person who remotely access the router will get VTY 0. And then 2, 3, 4, 5, which means I'm telling my router, you can accept up to 5 remote access connections. 5 administrators can log in into the router and configure at the same time. That is what the meaning of that is. Right? 5 connections it accepts at the same time. At the same time. Okay. Yes. So now what we'll do is line VTY 0 space 4. Let me give enter. Now I can see that line, I'm into the configuration line, which is I'm into the remote access connection. Now what I want to do is I wanted to first enable telnet, transport input telnet, right? This is a command that enables telnet, and I say login local, which means I need login and I need a username password login. That's what this command login local is. So let me give exit. Okay, so now we'll just go to do show run and see, guys, what we have got in the, if I give space, it takes me to the next page. And can you see here? Now, right now, when I see here, line VTY 0 space 4, and what command I gave? Transport input telnet, and also what I gave? Login local. That is also there, right? So with the help of the running configuration, or with the help of this particular command, wait, where is the command? Yeah, this guy. With the help of this command, I can know what and all the router is configured. So now with the help of do show run only, I can see whether telnet is configured or not. Right? So this says that the telnet has been configured. Okay, good. Now let me do one thing. I'm going to go to the admin PC where the connection got refused earlier. I'm going to close this guy, open putty application again, and type IP address 192.168.1.1, 1.1, and I'm going to choose telnet. Okay, I'm just going to give open. Okay, hope you guys can see it now. So let me just increase the font size. Change setting, appearance. Let me make it a little 16. It should be fine. Okay, good. So now you can see that I'm into the remote access connection or telnet connection to the router. Okay, let me try to log in with the username password that I created already, admin1. Okay, and password admin1 pass. Now can you see, guys, where I'm in right now? I'm accessing the PC, but inside the putty application, which device I'm accessing? I'm accessing the router. Okay, so now what I can do is, can you understand, guys? Usually we get this CLI from console only. We get the CLI from the console only, correct? Now we initially used the console cable. We did the console connection, and we enabled what? We enabled telnet. After that, I'm trying from this PC. I'm trying to use telnet and accessing the router from any location that I want. Right now, this PC is now in the office only. But if this PC is somewhere in the internet also, right, we can remotely connect to the router and then access them. Okay, yeah. So now what we'll do is we'll just go and give enable. Right, I'm just trying to get into the enable mode of the router. Okay, remotely accessing. This is what remote access is. I can be any location, but I can still access the router. So when I give en, I was expecting to get into the enable mode, but it says no password set, right? And if you see again, if I give en, it is again says there is no password set. right? It is asking for the enable mode password. And when I give en, it is saying that there is no password set. So there is no password, so you cannot get into the enable mode. And again, it is putting me back to which mode? It is putting me back to the user mode only. Okay. So now I what I understand from this is I'm trying to connect him via Telnet. He accepted the connection. He asked for the username password. I gave the username password correctly. After that, I logged into the router also, right? I gave admin one password and all. After that, when I try to give en, it is not taking me to the enable mode. So it is expecting what? It is expecting the enable mode password, right? So now what I understand is in remote access, what is mandatory? In remote access, what is mandatory? Enable mode password. Okay, if enable mode password is not set, if the enable mode password is not set, then you cannot go to the enable mode of the router. So you can stay in the user mode. You can stay in the user mode, but we all know user mode is not that great, right? User mode is a basic mode. So if you want to get into the enable mode, definitely what should be configured? Enable mode password should be configured. Okay, so always understand this. For remote access, enable mode password is mandatory. Okay. Okay. So now can I go and set the enable mode password from here, guys? Can I just go and set the enable mode password here? No, not possible because I cannot get into the enable mode. So from here, it's not possible for me to set the enable mode password. So what do I do? Where do I go? The only option I have is what? Console cable. Again, I go back to the router, connect my cable. This time I'm going to set the enable mode password. After setting it, I can bring my laptop to my place, and from there I can go and tell it to the router. Okay, so now again this guy is walking to the router, connecting the router with a console cable and connecting with the putty again. And now this time he enabled telnet already, but this time what are you going to do? You're going to set the enable mode password also. So enable mode password you're going to set. Okay, good. So now what we'll do is we'll just go in. Oh yeah. So here again, clicking on this router will get you the console connection. And here I'm going to set enable mode password. The command is enable secret, and I'll just use the command will be CCNA at NG this time. Okay, CCNA at NG, which means you have to study CCNA only in networking. Okay, so yes, so CCNA at NG. Now let me just go and try again here. Okay, this time I'm gonna go to EN. Password is CCNA at the rate of NG. Okay, cool. So now I got access to the enable mode of the router. So from here, there is nothing to stop me. I can go to configuration mode, right? And I can even go to the interface or I can do whatever I want. Yeah, I can do whatever I want. Now you can understand what is exactly happening, right? So from here, I logged into the router via Telnet, and I'm taking the CLI of the router from this place. Okay. I never went physically to the router. I never went physically to the router. I never used a console cable. Earlier, I used console cable. Initially, I used console cable. I was enabling Telnet. I was enabling the enable mode password. After that is done, I'm going back to my place. And from there, this time I'm going to use Telnet to connect to this particular router. Okay. So from now, what I don't want, from now, any changes or any configurations that I have to do on this router, I don't have to walk for the 2 minutes, use the console cable, sit in this place and do it. I don't have to do that. What I can do, I can comfortably sit in my place itself. I can sit in my place. I can Telnet to the router. Okay, so now I can do all sort of stuff things. Now what we'll do is right now um, in this router, right, let me take a screenshot again. Okay, so now our telnet into this router. I got the access of the router. Now I'm going to configure from this router or from this PC. I'm going to configure default routing. So default routing I'm going to configure. So hope you guys remember what is default routing. Right? What is default routing? A routing to any destination indirectly or no, in other words you can say default routing is nothing but what? A routing to the internet. So if you want to route packets to the internet or if you want to internet access, then you have to do what? You have to do default routing. Okay, we covered all these things in earlier classes, please. If you forgot, please check the recordings. Okay, so now what I'm going to do is when I take, see, assume when I try to from this PC, if I try to open the Chrome browser and if I try to go to internet, right, it's not working, right? It says nothing is working. Okay, so why it is not working is right now this router doesn't have a default routing. Right now, this guy doesn't have a default routing. You can check the routing table of the router. Okay, I'll show you here. Okay, so you can check the routing table of the router. Root show IP route static. Do we have any? Nothing. There is no static routing. There is no interrupt routing. So now what I'm doing is, I hope you guys are understanding what I'm doing. From this PC, I'm connecting the router. I'm trying to do default route, and then in this PC, I have a browser. From that browser, I'm going to check whether internet is working or not. Okay. Yeah. So now I'm going to configure IP route 0.0.0.0, 0.0.0.0. See, I'm doing all these configurations from where? From remote access, not from the console, right? I'm doing it from the remote access. Okay, what is an extra hop IP address? If you see the diagram, what is an extra hop IP, guys? From this router, what is an extra hop IP? 200.1.1.1, right? So that is an extra hop IP address 200.1.1.1. Okay, good. Cool. Now let me check do show IP route static. Now can you see I got a default route here and pointing into which destination is 200.1.1.1. Great. Now let me just go and make a refresh here. It's not working. I don't know why. Wait. Maybe I need to check the command prompt. Let's see. DNS is configured properly or not. I'm not sure. Okay, I think DNS is not configured. Yes, that is a problem. Okay, DNS is not configured. Yes, maybe instead of going to Google, see, we know you can just go to Google and make a check that is possible, or else maybe we know, right? If I try to open command prompting 8888, that makes sure that the internet is working. Okay, or else maybe if you still need only Google web page, just do this. Go to the local area connection, go to the properties. DNS is not actually set. Okay, so IP address you're getting from the DHCP server, but DNS you're not getting from the DHCP server. So let me set the DNS server to 88888. IP, fine, you don't have to configure IP, just set the DNS server alone. Okay, fine. Now let's go to the same browser, make a refresh. Again, you see it's working. What is this? Oh, it's Sandrayana. Okay. Yes. So now when I search for the network gig, you can see it's showing up here. So internet is working. Okay, fine. So now how internet worked? Because what happened was we went into this router. From this PC, we logged into this router, configured a default route, which means we configure a static routing like 0.0.0.0/0 can be reached via 200.1.1.1. I did that. So we were able to access internet from this PC. Okay. Yeah. So this is a simple task. And also maybe let's assume that, this admin, okay, now you don't have to travel, you don't have to walk for the 2 minutes to reach that router, right? Whenever you want to do some changes on the router, you can simply open the putty application, connect to this IP address, put the username, password, and then configure. Now, great. Now, what is this admin? We cannot expect the admin to sit in the office all the time, right? Maybe he just left the office now. Okay, left the office, and then he just went home, right? And now when he goes home, and now you call him as a normal internet user, correct? Because when he goes home, he's a normal internet user. When he comes to the office, I understand that this guy sits in this location, he can connect to the router. But when he goes home and when he connects to the internet, he's a normal internet user. Okay. So he's an internet user, but he works in our company as an admin. Okay. So now this company, this organization, this guy, since he's not available in the office, the organization is calling that guy, right? The admin is here. Okay, assume this admin. Okay, assume this is a phone he has got, right? He's talking. Okay, he's talking, and the company needs some support, but he's not at office now. He's at home, or he's in some location, he went for a vacation or something like that. Now, what this admin can do is, right? Since he's an internet user, and this router is also connected to the internet. Can you see the router is also connected to the ISP, which means he is also having internet access. This internet user is also connected to the ISP. He is also having internet access. Now, what we can do is we can make this internet user or the admin who is not in the office right now, somewhere else. We can ask the admin to remotely log in into the router from whatever location he is in, and he can configure the router again, right? So that's what I'm trying to show you right now. Let me go to the internet user PC, right? And then I'm just going to type Telnet, very simple, Telnet. And what IP address case? Maybe the router has got two IP, right? So this is an IP address. which I was using when I tried to connect from the inside. So 192.168.1. Okay, this is the inside IP address. Since the inter user is now on the outside, when the admin is inside, he is using this IP. When the admin is outside, he can use this IP address. So the admin is going to use the IP address 200.1.1.1. Sorry, 200.1.2, correct? Yeah, 2. So he's trying to connect from internet. He's trying to connect to the office router, right? For doing some remote support. Okay, now can you see it's asking for username password? What is username password admin? Maybe this time you can also log in as admin 2 even guys. Doesn't matter. Both user accounts works, right? Maybe I log in as admin 1 itself. Admin 1, what is the password? Admin 1 pass. Okay, there you go. You are into the router. Right now, EN. What is the command? CCNA at the rate of MG. Okay. So yeah. So now I can just do whatever I want, right? If I want, I can just go and configure some other IP addresses, or I can configure static routing. I can set the password. I can remove the password. I can add a user accounts. I can do all sort of stuff because now I'm into the remote access. I'm into the remote session of the router. Okay, isn't it cool, guys? Right now, one time you go put the console cable on this router, okay, and then enable Telnet, and from there you never wanted to go to the physical location of the router. You can just from your office itself, you can still remotely access them, or from home also, or from wherever you are, you can remotely access them. Okay, it's a cool feature. Okay, so now yes, uh, we understood that Telnet is so cool that you don't have to really walk anywhere, or you don't have to travel anywhere physically from from network access. You can Telnet to a router and access it. But here the point is why Telnet is not recommended. Right, I'll tell you why Telnet is not recommended. Okay, I'm just going to show you one thing very interesting, guys. I don't know whether I have used Wireshark in your course or not. Okay, usually in my actual CCNA class, every lab we deal with Wireshark, but here the course content is short and the duration is short. I have not used Wireshark. I think so. Maybe I think 1 or 2 classes I might have used it, but this time I'm going to show you one cool thing. I'm going to use Wireshark, and these guys are sending the packets, right? So this guy is sending all the packets, right? So Telnet session, you are sending packets to the router. So now what I'm going to do is I'm going to go and use Wireshark to capture the packets, right? I'm going to capture the packet and capture the packet and see what is inside that packet. Okay, let's see. I'm just going to use the Wireshark application for this. Okay, what I'll do is I'll just close this. I'm just going to exit the session, and I'm just going to right click. Okay, right click is not working now. Okay, capture. Okay, my mouse is not, my external mouse is not nice, I think, and I need to change it. Okay, so clicking on the capture, clicking on this interface, now we are capturing this interface of the PC, right? So now any traffic that comes into this interface or goes out of this interface, now it will be captured in the Wireshark. Okay, so I think Wireshark is opening. Okay, okay, we will please wait. It's initializing actually. Yeah, cool. Now what I'll do is I'm just gonna skip this version. Don't update it. Yeah, Telnet. I'm just gonna search for Telnet packets alone. I searched. Can you see? I typed Telnet. Okay. Now what we'll do is, guys, I'm just gonna go to the PC again. Right. Again, I'm gonna open the PuTTY application. Choose the protocol as Telnet 192.168.1.1, and I'm just gonna go and give open. It's asking for username password. Let me increase the font size again. Change setting appearance. Okay, 16. Okay, cool. So now it's asking for username password, right? Let me give the username password admin1 pass. Okay, I logged in. Right now when I give EN, it's asking for the enable mode password, which is CCNA at the rate of NG. Oh, CCNA at NG, CCNA at the rate of NG. Okay, maybe I gave the wrong password initially, but what password I gave wrong, we can see in the capture. See, that is what the interesting part is. And the capture is going on behind, right? Okay, now I'll give show run. Sorry, show run. And I just give this, I'm seeing the output, everything is good. Okay, now we'll just go and see the capture space. Now, whatever packets that this guy has sent, it has been captured by our application. The name of the application is Wireshark. This is the beauty of Wireshark. Wireshark is very important networking tool. See, in this course, I didn't give you very good clarity about Wireshark, I know, but really Wireshark is a very important tool. In my actual CCNA class, I discuss more about Wireshark, but here we don't. Let's go to the Wireshark application, and here you can see so many things I can see here. Now what I'm going to do is, guys, these are telnet packets. Right now, what I'm going to do is I'm just going to go and see what payload they have, right? What message they were talking. That is what I'm trying to see here. So for that, what I'll do is I'll right click. Each and every packet is sent between the router and the PC. Can you see? This is router IP address. This is the PC IP address. Let me right click and I'm going to say follow TCP stream. Show the message, show the conversation that they made. When I click on TCP stream, you can see, right? And what is the username, guys? Username is admin. Can you see it clearly? Now, when I capture the packet, I can see the username. And what also I can see? Password, right? What is the password? Admin1, that is the password. Right? And also, can you see when I give EN, it was asking for the password first time, no? That time, what I missed that A. I gave CCN at NG. That is why it was asking the password again. Next time I gave the right password, CCNA at the rate of NG. Now I got into the router. After that, I gave a command called show run. And now I can see the output of the show running configuration. Can you see guys here? This is very, very dangerous. Because why? Because I'll tell you, see, there are many, no, there are many even devices. For example, there is a device called sniffer. Okay, this sniffer is like a small switch. Now, what you can do is, people can do is, maybe if someone wanted to know what you're really selling, now what they can do is, they can bring, this is a small box case. It's a just small a switch with 2 ports. Okay, it has got only 2 ports. Now I can bring that sniffer over here, which has got 2 ports, and I can disconnect this cable. I can connect uh, that cable to the sniffer, and I can connect one more cable from the sniffer back to the switch, right? Now what happens is this sniffer will store all the packets I'm sending. It's going to store all the packets. You can do it, right? The sniffer will hardly cost you somewhere around 2000 rupees a day, I think, guys. You can buy it from Amazon, whatever platform you can buy it from. It's a sniffer, just a small cost sniffer only. And can store all the packets, right? Assume now someone without your knowledge, they kept a sniffer like this, right? And you are trying to log in into the router. Okay, assume that you are using a telnet protocol. Okay, and when you give telnet, it'll ask for username password. Right now, what happens? Every conversation that you make with the router is captured. Okay, now after the router is asking you the username password, you give the username password, right? That username password is also getting stored and going to the router. And again, the router will give a response, right? That is also stored. So every conversation that you make between the PC and the router is stored by this sniffer. Right? Later, what this hacker can do is, or this bad guy can do is, he can just take the sniffer back and connect that directly to the switch. Now he can connect the sniffer to his PC, and you can see all the packets, right? All those packets are going to exactly look like this, right? All those packets are gonna look like this only. So now what this strange person, what this the bad guy can know, the bad guy knows that the username password is nothing but what it is, admin and admin1 pass, right? And all he knows the enable mode password is what, CCNA at the rate of ng. Okay, so this is very, very bad, right? Okay. Maybe if you have some questions like, how can someone come to my office and without my knowledge, how can I connect a sniffer? I agree. But what if you are colleague, right? Maybe let's say you are a senior admin. Okay. And there is one guy called junior admin who's working with you. Okay. He's your junior. Right? He's your assistant. What if the assistant does it? We never know. No, we cannot believe anyone in the organization. Right? You are a good guy, right? But he doesn't like you, the junior admin. So he just wanted to sack you. So what he did is he just connected a sniffer. He came to know what is the username password. And now when you are not in the organization, the junior admin can log in with your username password and he can crash the router also. Okay, that's possible. Okay, so maybe junior admin can be a bad guy, but generally organizations, we trust everyone, right? Maybe they are our colleagues, we work for the same company. Maybe the chance of this junior admin being a bad guy is less. Okay, maybe in that case, just think about the other direction. Like, what if you try to telnet from here? This is this is your PC, you are in the internet, and you're using your laptop, and from the internet you're trying to telnet. Now again you are sending the username password, correct? The username passwords are in clear text. Understand, that is what the problem is. When you send the username password, the username passwords are clear text. And now you're sending into which network? You're sending this into the public network. What is public network, guys? Internet is what we call as public network, right? So internet is public network. Now, what if someone places a sniffer over here? This is not your company. This is not your infrastructure. Can you understand? This is your organization. This is your organization's infrastructure. No one can come and connect that without your knowledge. But if someone connects a sniffer over here in the internet, will you be able to know that? Definitely not. We never know what is happening inside the cloud. The cloud is a most strangest place I know, right? We never know what is happening inside the cloud. What if someone keeps the sniffer over there and you send your username password, which happens to be clear text, and that guy, that hacker now knows username password, and now he connects back to the router and crashes your router. It's so dangerous using Telnet. Why so? Because in Telnet, whatever conversation that we make, right, username password you send, or you send the enable mode password, or whatever commands you type, everything happens to be clear text. Okay. So in clear, if anything goes as clear text, anyone can capture that and see it. Okay. That is why I never recommend Telnet. So what is the solution then? The solution is SSH. The solution is SSH. Okay, it's a real nice cool protocol. Like, see, it's remote access only, right? Both are remote access. The purpose is same. Telnet is not recommended, right? You don't recommend it, not recommended, because it is clear text, right? It doesn't have any encryption. It is clear text. What about remote access? Sorry, what about SSH? So it's a cool protocol, right? It is recommended. That is the only standard that we are using. Recommended. And then it doesn't send clear text. What it does is it encrypts the packet, right? If you send username, password, or if you're sending anything, that gets encrypted. Okay. So yes. So to learn more about encryption, how things are working, to get a more clarity on encryption part and all, I would recommend you guys to take my free cryptography course that is available in the app as well as in the LMS, right? Cryptography course. Okay, just go and check that. It's interesting stuff. Okay. So now here we're gonna go and disable what? We're gonna disable telnet. Telnet never do it. It's very, very bad, right? So it's a very weak clear text protocol. Don't do telnet. Instead, disable telnet and enable SSH. Okay. So SSH is going to have an encryption happening over there. So it's going to be really nice. Okay. So now what we'll do is we'll just go and understand how to disable telnet first and then enable SSH. Okay. So here I'm just going to go to the same router. Okay. Sorry, password it's asking for CCNA at ng. Okay. CCNA at ng. Okay. Configuration mode. I need to go and go to the line VTY, right? Line VTY. That is what the remote access phase is. And I'll say no transport input. I say I'm disabling the remote access connection. And after that, I'm saying transport input. This time I'm saying what? I'm saying I want to enable SSH. See, understood? First, I was saying no transport input, which means don't accept any connections. I told. So it disables telnet. And then I say transport input SSH. Just enable SSH. Okay. So now I did that. So now after this, what you have to do is, see, there are certain prerequisites for SSH. Configuring telnet is so easy, but configuring SSH is also easy only, but there are few requirements that you guys have to have. First, you have to change your host name. Host name cannot be a router, right? So Cisco found there is a vulnerability. So if they have a host name called router, they feel it's weak. So in order to have SSH enabled, this command alone will not do that, right? This is enabling SSH, but we have to do a few more things also. First thing is you have to go and change the host name. I'm just going to make the host name as R1. Okay, and after that, first the host name. Next, you have to have something called domain name. Okay, again, know what these guys are. We don't have time here to discuss. Please check my cryptography course. There you'll understand everything clearly. So domain name you have to set. So what is the domain name? Why domain name is required? Everything you will know there. Okay, I think is it domain? Okay, I think okay. So I'll just choose the domain as ng.net. Yeah, or you can use whatever you want. I'm just using networkgeek.net. Oh, sorry. Oh, sorry, guys. No domain. That's not the command actually. The command is IP domain name. Yeah, this is the command. Okay, so many commands are there. Sometimes I get confused. The command is IP domain name ng.net. So after giving this command, I'll also give you the commands in the LMS portal, guys. So please check when you want to configure this. You also have the commands over there. You can refer to the commands that I've uploaded in the portal. Okay, so yes, next thing is we need some keys. So host name is done, domain name is also done. Now we need to generate some keys. Okay, keys are really important. These are the encryption keys. Okay, encryption keys. We want to have some encryption keys. So that's the third thing. So let me just go and generate the encryption key. So key, sorry, crypto key generate. I'm just gonna generate an RSA key with a modulus of 1024, right? Again, cryptographic content. Want to know what is modulus, what is 1024? It's a size of the key actually, right? So how big you want the key to be, right? The more big it is, it's very difficult to break it. But at the same time, the more big it is very resource intensive also. So 1024 is a nominal number. Okay, it says the key has been generated with a size of 1024 bits. Okay. Yes. Now it says what SSH has been enabled. Very good. So now what we'll do is we'll go to the same Wireshark capture. So which was having the Telnet packet. Now same Wireshark we'll do. I'm just going to capture here. Click on this. Okay, please wait. Okay, there you go. This time I'm going to select SSH. Okay. So now what I'm going to do is I'm going to go to the PC, right? This Windows machine. This time, instead of choosing the protocol as that's what we were choosing earlier, right? This time I'm going to use SSH. Okay, and then the destination IP is going to be the same 192.168.1.1. And now we're going to connect to the same device, but with the protocol SSH. The Wireshark is happening there, capturing the SSH packets. We'll see. I'm going to give open. It says you really trust this device. It's asking, yes, I say I trust this device. And now let me increase the font size again. Okay. Okay. So login is what is the username, guys? The login is admin1. What is the password? Now can you see it's asking for the password? Authentication, then password is asking for. The password is admin1 pass. Okay. I'm able to log in. The password is successful. I mean, when I give EN, it's asking for the enable mode password, which is CCNA at the rate of NG. Okay, I was able to log in into the user mode, sorry, enable mode, show run. Okay. Yes, I can see all stuffs. Now we'll just go and can you see guys, SSH packet has been captured. Okay, so can you see some key exchanges are happening, right? It's a nice Diffie element. It's a fantastic concept. Right, I strongly recommend you guys to check my free cryptography course where you understand exactly how Diffie element works and all. Okay, so let me right click, follow TCP stream just to see what is inside the packet. Okay, all the messages we are taking and capturing right now. And now if you see here, initially there was some negotiation happening, right? Some encryption protocol, encryption keys negotiations are happening. And from there, can you see anything here, guys? Can you see anything here? Can you understand? You can see, but can you understand what it is? Okay, here is where somewhere my password is. Here is where somewhere my username is. Here is where somewhere my enable mode password is. Everything is encrypted. Okay. So now I don't have to really worry. Even if I'm out of my network, even if I'm from internet also, I can do SSH without any problem because why? Even if someone is capturing my packet, all they see is what? They see only the encrypted content. Can they do anything with encrypted content? Nothing. They cannot do anything with encrypted content because it doesn't make sense for them. Only if it is plain text, they know what the password is. But if it is encrypted, they don't know what the password is. Okay. So that is why I strongly recommend you guys to use SSH, right? Wherever you are in, don't use Telnet. Either you are inside the office also or you're outside the office. Don't use Telnet. Use SSH. That is what that is what the recommended protocol is. Okay. So even here also, I have a server here, right? I have a server in my office, right? I have an office in Chennai. in Vadapalani. Okay, if you guys are near this place, just come down. We can have a meet. Okay, okay. So this is where my office is in, and right now I'm in my office only, and I have this NG lab server, right? Which the one that you guys are accessing to do the labs. Now, whenever see the NG lab server is just in the next room. Okay, if I just walk for 10 seconds, I can go to my NG lab server. But you know what I do generally is I don't walk to the 10 minutes, go to that NG lab server, and I won't physically access it. Instead, what I'll do, I have my own room, right? In that from that room, what I do is I'll just go and SSH to this guy. Okay, I SSH to that NG lab server. And here I can even show you that. So when I go secure CRT, it is like some kind of an application like Putty, guys. So I use secure CRT. I like it. But Putty also possible, right? You can also do it with Putty. Now, can you see? I have this. Now, when I try to connect, now can you see what happened? I logged into my server, right? So don't think that SSH is only for routers, right? SSH is also possible for Linux machines also, right? And you can see I'm running Linux machine here. This is the lab server, and it is based on an Ubuntu OS, and you can see few stuffs over there. Now I'm SSHing it, which means the server is just next to me. It is just in the next room. But still, also, I don't trust anyone. I wanted to do SSH on it. Even when I go home, also, I still SSH to my server so that no one can find what my username password is. Okay, because it's encrypted. Perfect. So yes, so now we understood what is Telnet and what is SSH, which one is recommended, why it is recommended, those things and all. Right? The configuration commands are also I'll give you along with the video I upload. I'll give the commands too. Right, you can check with the configuration. Right, and all these labs are free only. I don't know how many of you are doing the labs. Okay, that is important. If you're simply joining the live sessions, then that's not going to be really effective, guys. You have to do the labs also. Right, that is why we have given free labs. Commands are given in the portal. All you need to do is just spend some time and practice it. That's it. Okay, so now let's go and understand the next important things. I'm just going to start with this OSPF, or maybe before going to OSPF, let's compare this console connection and then remote access. So I just wanted to compare these two. Okay, what is it? What is the differences they have? Okay, I have one particular. I don't know whether I have it right now. So I don't have it. Maybe I transferred all my files to a different device. So I don't have that. Okay, let me tell you guys. So first thing is console connections, you can do it only from physical location. Okay, so which means if you are establishing console connection, you have to be physically near the router, right? But if you are remote access, you can be remotely anywhere. You can be anywhere. So physically near the router, and here you can be anywhere. Okay, that's the first point. And next thing is, a console connections, you can allow only one user, right? Only one user can log in the console connection because there is only one console port, right? But when it comes to remote access, if you have 5 admins for your router, all 5 admins can log in, which means multiple users can log in the remote access, right? So there is no restriction, right? Here only one user, here multiple users can log in. Users means I mean by not a normal user, I mean by admin. Okay, one admin, but here multiple admins can log in into the router. Okay, and next thing is see here console connection. There is no configuration required, no pre-configuration. I'll say pre-configuration, no pre-config required. So what I mean by that is you can buy a router, right? A new router. You can unbox the router and you can go and connect. You can just go and establish the console connection to the new router. No pre-configuration required. There is nothing you need to have on the router as a configuration in console. Okay. Whereas if you try to remote access, when you try to telnet or SSH, right, what is required? First, you have to enable, right? You have to enable remote access. That is the first point. Next, you have to set the enable mode password. Enable mode password should be set. Enable mode password should be there. And also the interface should have IP addresses. Can you understand? These are the things that we have to do before itself, right? So which means remote access needs all these things. Okay, so just like that, you can connect to the console of any new router. But can we remote access a new router? No. The new router should be taken. First, we have to enable remote access through console. We have to enable remote access, enable mode password, assign IP address to the interfaces, and only then you can go and do remote access, right? Okay, and then maybe you can use all commands, right? All commands I can use here. All commands means I can use all commands. But here, there are some commands which you should not use here. Maybe I'll tell you, listen here. Now, here I'm into the SS section, you know. Okay, I go to the configuration mode of the router. I go to the interface G0/0, this interface. I'm going to this interface. I'm into that interface. And what if I, by mistake, I gave a command called shutdown. I gave shut command. Generally, we give no shut to enable, right? By mistake, I gave shut command. What's gonna happen? See, we'll just give and see. That's it. Now the interface is down. Now this interface is down. You cannot connect to that interface again, like because the interface is down. Now what you have is you can connect to the console interface of the router, and then you have no shut it, or maybe from this direction you can SSH, and then you can give no shut. But there is no way that you can. You need to this interface in shut state. You have to give no shut. After that only you can connect to that interface back. So either you can go to console and then give no shutdown, or you can message from this side and then give no shutdown. Okay, because these are something very bad. By mistake you gave shut command. Again, you don't have any other option. You have to go to the router, connect through the console cable, give no shut, and then only again remote access is possible. Okay. So like this, there are many commands. All commands are possible. Right here, you should not use commands like shutdown commands. About those commands, if you use, that will kill the connection. Okay. And here there is nothing. There is you can just do all commands you want, whatever command you want, you can do. And this is kind of, I say it's more secure, because why more secure? Because it's more secure because it is who can access console connection base. Let's say I believe most of you guys are working in office, or maybe you're working in your college. So you're studying in your college. See, can I come to your office and can I connect a console cable to the router that you have in your office? Case every office has got a router, definitely. Can I go and connect a console cable? No, right? Because if I have to connect to the console cable, then first I have to come into your company. Can I just take that come into your company? No, right? There are many restrictions. A normal stranger, right, who is walking in the road cannot come into your company. They cannot come into the data center where you generally have the router. Not possible. So that way, console connection is more secure because only people who belongs to the company only can get into the room, and then you can connect the cable and they can do. So in that way, I feel console connection is more secure because the nature of console connection is like that. But what about remote access, right? So if your organization is having a router, right, all I need to know is just the IP address of that router. Okay, if I know the IP address of the router, and your office router is anyway connected to the internet, and I'm also connected to the internet. This is me, right? From my laptop, if I know the IP address of your router, I can just go and do SSH or Telnet to your IP address, and I can at least try, even though I don't know the username password, I can randomly try some easy username, guess I can guess the passwords. So that way I say this is less secure because why? Because it is open to everyone. Telnet message is open to anyone in the internet. It's open to the public, but console connection is not open to everyone. It is closed. It is open only to the people who work in that company as a network administrator, not to everyone. Okay. That's why I say let's secure. Okay. So I can also list few more points also, guys, but I think this is sufficient to understand the difference between telnet and SE. Sorry, the difference between console and then remote access. In remote access, which is a recommended one? This is bad. Which is recommended? SSH. You know why it is. Okay. Yes, cool. Now let's try to understand the next topic, which is OSPF, Open Short Path Test. So, see, OSPF is actually a very big topic. Again, I know I'm saying this in all my classes because I want you guys to understand that, this is not uh, this is not what I teach in my actual course. Maybe if I'm just going to spend only 30 minutes on OSPF, it's not more than that. But you have to know this is not what the actual OSPF is. Right? The real OSPF will take, I'll show you here. Just glance and show you. Okay, I'll just go to networking syllabus CCNA, and this is the actual CCNA syllabus. We covered hardly few topics here, but when you go to OSPF, can you see OSPF starts from here, from point number 40 OSPF is starting until 49 OSPF is going. So almost 10 topics I've got for OSPF alone. But in this 10 topic, to teach this 10 topic, it will hardly take me at least, somewhere around 20 hours to teach OSPF. Okay. But here I'm just going to basically say what is OSPF, the purpose of it, and very, very minimal level only I'm going to teach OSPF in. Okay. Yes. So understand what OSPF you are learning here is not the actual complete OSPF. Right? There are so many things that you can understand in OSPF. It's a very important concept. Okay. So yes. So we'll just go with this concept first, dynamic routing. So first, let's understand uh, the problem way. So this is what I generally say in all my classes. Okay. So we did static routing, right? So can you guys guess what is the problem that we have in static routing? In static routing, what problem? Static routing means manually we do it. So we manually configure routing entries, right? So we can go manually, we add entries into the routing table of the router. Okay, so if it is just two routers, okay, I hope you guys attended my static routing session already. We did 3 labs in static routing. Okay, so if you just two routers, assume that you have 1.0 here, you have 2.0 here, and you have 3.0 here. So here we have 3.1, here we have 3.2. Okay, assume these are the two interfaces. Now what we do? We go and configure static routing. It's very simple. This router knows about 1.0 and 2.0. And we go to this router one and say that 2.0/24 network. Like the mask can be reached via 3.2. So we simply go and create a static routing here. Okay. This is yes, static routing. The same way, I go to the second router and we create second router knows which two networks. It knows about 3.0 because that is directly connected. It knows about 2.0 because that is also directly connected. It doesn't know about what? It doesn't know about 1.0/24, and that can be reached via 3.1. This is what simple static routing is. The same static routing, when you are doing with two routers, can you, can you do that with maybe let's say assume you have 100 routers, R1, R2, R3, right, R4. I'm not going to write all the 100 routers. So assume you have router number 99 and router number 100. Okay, all these routers are so complexly connected. Okay, they are connected like this, they are connected like this. No, they are connected like this, they are connected like this. So now, if you have 100 routers, right, you're gonna have many networks. You're gonna have many networks. Okay, so now with this many networks, can we configure static routing? First, understand the problem. So before you learn a topic, you have to understand the problem. So static routing is not possible in this domain, in this setup, in this architecture, where you have hundreds of routers. Static routing is going to be really tough. Okay, so that is where these networking people they identified 40 years back itself, not 40 years exactly. I can say 35 years, somewhere like that. 35 years back itself, they started developing routing protocols, right? So they started developing dynamic routing protocols. So dynamic routing protocols. So there are many dynamic routing protocols. There are few protocols still we use, but there are many protocols which started using, but now it is not that great, so we dropped it. Okay, so one such protocol which is very popular, but now no one is using it. This is RIP. Okay, RIP, Routing Information Protocol. So RIP stands for Routing Information Protocol. Information Protocol. Okay, and the other one is we have OSPF. Okay, so OSPF. See, the age for RIP and OSPF is not that big. I think RIP was developed in the year 1988, I guess so. Maybe I may be wrong with the year, but not very far away. Lot 1988 or 1997, and this guy also 1989. So 1989. Okay, so if you see that the age difference between RIP and OSPF, OSPF is just 1 year younger than RIP. But the RIP is almost done, right? The life of RIP is done. No one is using RIP nowadays because it is not that great protocol, great dynamic routing protocol. So OSPF is no, still now it's great, right? Many organizations even today they use OSPF, which was developed in the year 1989 and it has been updated in the year 1991. Okay, so 1991 the protocol has been updated. That is the version that we are using even till now. So 32 years we are using this protocol and is very dominating. And also few other protocols also equivalently popular. Like there is one protocol called EAGRP. Okay, that is also very popular, used in many places, right? And there is one fantastic protocol called BGP, okay, which is the protocol for internet. If internet is working for you, if you're joining the Zoom session with the internet, that is because of this protocol called BGP, right? Likewise, there are many other protocols, like there is a protocol called ISIS, there is a protocol called IGRP. So all these guys are developed for the same reason, dynamic routing. They are dynamic routing. They came to address what? They came to address the problems that we have in static routing. In static routing, many networks, static routing is not possible. So we can just go and use any of these protocols to solve the problem that we are facing with static routing. The solution is what? Solution is dynamic routing. You can use any one flavor. We're gonna just learn OSPF here and understand how routing protocol basically works. Okay, for the point. Okay, so yes, we'll start with by understanding what is dynamic routing protocol. I mean, we understood what is dynamic routing protocol, but we'll get a clarity of how it works. Okay, so now assume that you have router 1 and router 2. Okay, two routers are there, and these two routers are connected with a network. Right? Assume that you have a switch here, switch 1, you have PCs over here, switch 2. Okay, so generally how we assign IP addresses? 1.1, 1.2, 1.3. 3 point, assume that I have 2.1 here, 2.2, 2.3, and I have 3.1 here, 3.2. Okay, so these are the IP addresses I have. Now, basically, what we do is now what networks he knows already, right? When you see the directly connected networks, what networks router 1 knows it? 1.0. What networks router 1 knows it? 3.0. So these are the two networks, they are directly connected. It's already there with the router because it is within. Now, here when you take router 2, this guy has got directly connected 2.0, directly connected 3.0. So these are the two networks that this guy has got. So now what they don't know, that is what important, no? What they don't know, if I ping from here to here, it's not going to work because why? Because when I send the packet to the router doesn't know where is 2.0, right? So it's going to fail. Okay. So now what we do, so generally we go to static routing and we add, right? So that's what I told you. You add 2.0/24. In static routing, you say that can be reached via 3.2. Here also you say 1.0/24 can be reached via 3.1. But we gonna not do that because static routing is not efficient for large networks. So what we're gonna do is we're gonna make the routers to talk to each other. Yeah. So we're just gonna make them to talk to each other. Instead of we go and say what network is which side and going and saying here which network is on which side. So here, here what we're gonna do is we're gonna just go and make the routers talk to each other, right? So we're not gonna basically do any much works here. Of course, few works we have to do, but most of the works are done by the router itself, right? I'll simply tell you guys how the process happens. So this router is going to make an advertisement. Okay, so what is advertisement? So if I have some product with me, how will you guys know it? I have a product, I have a company, I have a product. So how will you guys know? Only if you advertise, you will know, right? So now the same way, routers, they will start advertising it. Okay, so they will start advertisement. Okay, what advertisement they're gonna do? So here, what networks they have got, right? Here, generally companies, what they do, they advertise the product they manufacture, right? So now in routing, in dynamic routing protocols, the router is gonna advertise the networks they have. Now router 1 is gonna go and say, router 2, he'll say, hey, router 2, you know what? I have got 1.0 and 3.0 with me. These are the networks that I know. Okay, router 1 is saying to the router 2. He is advertising. Can you understand? Router 1 says to router 2 that I have got 1.0 and 3.0. Now, the same way, what router 2 will do, right? Router 2 will also advertise, right? Because what network he has got with him? 2.0 and then 3.0. So these are the two networks that router 2 has got. So now basically what happens is, right, if I advertise what you guys are knowing, assume that, I'm a person who's advertising to you something. You will know, right, okay, this product this guy is basically selling. Okay, maybe now you're coming to know that what product I sell, or maybe what is the name of my product. And maybe in future, if you need the product, you will be contacting me, correct? Same way, when router 1 is doing the advertisement to router 2 will see the advertisement. Okay, now this packet is sent, this advertisement packet is sent to router 2. Now router 2 is exploring. Okay, what networks, what router 1 wanted to say? Router 1 says that he got 1.0. Router 1 says that he has got 3.0. Now, which network is already with him? Now compare this advertisement with his routing table. What network is already there? Can you see 3.0? This router already has got 3.0. That is there in the advertisement. So we're going to ignore this. Because why? Because I know 3.0 already. But something that you told, no, 1.0, that is not in my routing table, right? 1.0 is a new network for me. 1.0 is not in my routing table. What happens is router 2 will take 1.0, it will add into the routing table automatically. That is the benefit. Based on the advertisement we get from router 1, right? The advertisement is going to happen from router 1, it goes to router 2, and router 2 takes that packet, opens that packet, and sees, okay, router 1 says that he has got 1.0. And what is the next hop IP address? From where the packet came from where the advertisement came from? The advertisement came from 3.1. So that is going to be the next hop IP address. What the point? So this is what we do statically, guys. Now, what we do statically by typing commands, now the routers, they can automatically understand with the conversation they have got. Okay, so now this entry is automatically added into the routing table of the second router. Now what second router knows? Second router knows about 1.0. Because of whom? Because of, not because of me. I didn't configure any static routing. Who told him? Router 1 told router 2 that he has got 1.0. Now the other side is easy, you can understand. Router 2 router 2 gave one advertisement to router 1, right? And router 1 is going to open that packet again and see that he's going to compare his routing table with the advertisement. 3.0 is something that he already knows it. So no, 3.0 is not an interesting update, but we can see that 2.0/24 that can be reached via what is a which router advertised 3.0, right? So that is going to be the next hop IP address. Okay, so can you understand? So this is what a dynamic routing is. So we'll discuss more about this OSPF related the concept or OSPF related configuration in tomorrow's class. Maybe I think maybe 30 minutes I'll spend on OSPF configuration tomorrow. But this is what the core idea is. This core idea is the routers, they talk to each other and they advertise networks. So as a human, I have a very less work to do. Okay, so they talk to each other and they update the routing table. That's it. Okay, so with this, I'll finish today's class, right? So we didn't complete OSPF. We started this, we just understood dynamic routing generically. I didn't go anything into the specific OSPF concept. Tomorrow we'll start with OSPF and then we'll try to understand some basic OSPF configurations. Maybe one lab only I'm going to spend on OSPF. Okay. Okay, so we'll end this meeting here. See you guys tomorrow. Thank you. Bye.